Now, this next question right here, example 2, I'm actually just going to strike this one out. We will be touching on this. I'm trying to cut down the amount of repetition that you guys are going to see, so we'll get to questions like this in a little bit. For example 3, I do believe there's a lot of value in this, but we're just going to roll through 2 of them because these are pretty easy. I just sort of want to make sure that you guys know how to check that you're doing this right. Now for this one, it says determine to 2 decimal places. So that means that we're not going to use the unit circle. Instead, we're just going to punch this straight into our calculator. The big game with this is just making sure that you can switch from degree mode to radian mode. And you can also go and look through the key to get the rest of these answers. But for my first one, I go sine 280. You guys notice 280 degrees, so that tells me it's going to be in degree mode. I go sine 280, and this will give me negative 0.98. And it's 984, so that means it's going to round to 98. When we see this tan 7 pi by 6, so what I'm going to do is I'm going to go to my calculator, I'm going to switch it to radian mode, and then I'm just going to punch in the tan of 7 pi, and then we divide that by 6. So when I punch that in, this gives me 0.58. Again, I'm not going to spend too much time on this because it is just calculator jockeying and pumping into your calculator. But instead, we're going to move on here. Now, these questions are actually pretty cool. Given the terminal point of an angle theta in standard position, we can find the exact values of the 6 trigonometric ratios. So these ones are kind of like our harder questions of the one that I skipped up there. Given that the point P, negative 3, 2, lies on the terminal arm of angle theta, find the exact values of the 6 trigonometric ratios. Now, one thing that I do want to bring up to you guys here is it doesn't say we're on a unit circle. So what we're going to have to do is we're going to have to find that hypotenuse. The first thing that I do is I draw my coordinate grid right here. So I draw my coordinate grid, and we're looking at the point negative 3, 2. So negative 3, 2, I go negative 1, 2, 3, and I go 1, 2. And that gives me that point right there. Now, very, very important. I'm going to draw my triangle a little bit better there. But very, very important. If you remember from way back when, we always said that triangles come from the origin and then go down to the x-axis. So you'll see this a bit later again, but as I draw my triangles in the quadrants, my triangles also always have to look like this. They start at the origin, the hypotenuse goes to its point, and then it goes directly down to the x-axis. If you don't draw your triangles like that, what's going to happen is you're going to start making mistakes. So right here I have negative 3, and right there I have 2. So looking at my triangle, I want to find out what my hypotenuse is, or what my other side is. So we go, well, the square root of negative 3 squared plus 2 squared, which is going to give me the square root of 9 plus 4, which equals the square root of 13. Now, the square root of 13, we're always going to accept the positive value of it. Looking at positive negative is a very, very, very 1/2-dimensional thing. So what I mean by that is going directly left and right, we can assign a positive negative. Going directly up and down, we can assign a positive negative. When I'm going at an angle, I can't really assign a positive negative unless we get into physics and vectors, which we're just going to pretend doesn't exist for our purposes right now. So now, that gives me that my hypotenuse right there is 13. So I'm just going to, or root 13, I'm just going to quickly redraw my triangle right there. I have 2, negative 3, and root 13. My theta is always going to come from the origin, so I'm just going to put that in right there. And then we want to find the 6 trigonometric ratios. Sine theta equals opposite over hypotenuse, so 2 over root 13. Cos theta equals adjacent over hypotenuse, negative 3 over root 13. tan theta equals opposite over adjacent. Remember, we're always going to move the negative to the top, so I get negative 2 over 3. Then my cosecant theta is just the reciprocal of sine theta, so that gives me root 13 over 2. My secant theta is just the reciprocal of my past one, so that's going to give me negative root 13 over 3. And finally, my cotan theta is going to be the reciprocal right there, which will give me negative 3 over 2. So that would be my 6 trigonometric ratios. The point A, negative 5, comma negative 12 lies on the terminal arm of angle theta in standard position where theta is less than 0. Find the exact values of the 6 trigonometric ratios. So here we again draw this out, and I go negative 5, negative 12, so that means we're going to end up in quadrant 3 there. And you guys will notice I have not drawn this even close to scale. Don't worry about that. It's just a little sketch. So then we go the square root of negative 5 squared plus negative 12 squared, which would equal the square root of 25 plus 144. And just to make sure that I don't make a stupid little mistake right here, this gives us the square root of 169, which actually ends up equaling 13. And again, we're going to keep the positive of it. And if you guys remember your triangles, this is actually what we call a 5, 12, 13 triangle. So now we have to list off the trigonometric ratios. Sine theta, cos theta, tan theta. Sine theta is opposite over hypotenuse, so negative 12 over 13. Cos theta is going to give me negative 5 over 13. And tan theta is opposite over adjacent, which is 12 over 5 because my negatives cancel. From there, I have cosecant theta, and cosecant theta is going to give me negative 13 over 12. Notice how I move the negative sign to the top? You will lose notation marks for not moving that negative sign. This would give me negative 13 over 5, and cotan theta will give me 5 over 12. Voila! So, moving on, positive and negative trig ratios, we will get to this in the next lesson.